Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on Mathematics Grade 11, a four-part series, and this is video 3 of that four-part series. And this question comes from the November 2023 Gauteng Province Department of Education, and this is the chapter of Exponents and Surds. 2.1 goes, simplify without the use of a calculator. So what you do whenever you've got questions like this is all right, if you don't know how to convert to your exponents from numbers to exponents, you use your calculator not to solve the problem but to convert your numbers to exponents. So you go 512 equals to shift, and then you press the button. Fact, it will convert it for you, and that is 2 to the power of 9. All right, same thing for 64, but before we do that is we want to change this negative exponent to a positive one. So what we do is we flip the fraction upside down. What's at the bottom, we take it to the top, and what's at the top, we'll take it to the bottom. That is an effect of changing the sign of your exponent on the outside. So we'll do that first. So that'll be equal to 512 x to the power of 3 all over so we do it the other way around. It will be 64x to the power of negative 3 over 512 x to the power of 3. We flip that upside down and it will give us a positive exponent. Now what we do is we use our calculator to convert these numbers into exponents. 64 gives us 2 to the power of 6. So that gives us 2 to the power of 6 x to the negative 3 over, and 514 we noticed 512, that gives us 2 to the power of 9, that is x cubed, and that is all over all to the power of 2 to the power of a third. So now what we do is we take this to the bottom and fix this too. When we divide powers of the same base, okay, powers of the same base, we add we subtract the exponent of the power at the bottom. So this one gives us 1 over, okay, we take that, becomes 2 to the power of 9 minus 3, and this gives us x to the power of 3 plus 3, all raised to the power of a third, and that gives us 1 over 2 to the power of 9 minus 3. Sorry, that's 9 minus 6, not 9 minus 3. Okay, I made a mistake. 9 minus 6, excuse me. So that leaves us with 9 to the power of 2 to the power of 3 at the bottom, and that is x to the power of 6. So now what we do is we apply the exponent outside. So that is 1 over 2 to the power of 3 times 1 over 3 times x to the power of 6 times 1 over 3. That's what the effect that has when we raise a power to another power. That leaves us with, okay, so now the 2's, the 3's cancel out over here, and over here we get, this is 2 and 1, so that leaves us with 1 over 2 x squared, and that's our answer. Next question. There are many ways to kill a cat, so you could have approached this a whole totally different way. As long as you get the right answer and it makes sense, we're good. 2.1.2 says simplify without the use of a calculator. So what you do here is we factorize the numerator so that we can see exactly what's going on there. So let's factorize the numerator. All right, when we factorize the numerator, we are going to use the method of grouping to factorize. So match, 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 match. We're going to match this one with that one and this one with that one, and you see what we're going to achieve right now. We want to achieve x squared minus 1. So we group minus x to the power of n. That will give us it will give us what we want to achieve. Okay, minus, okay, plus. All right, and then we match x to the power of n plus 1. You could do it. There are so many different ways you can do this. I'm just choosing this one because this is the quickest way to get to the goal that I want to get to, and we match that with x to the power of n minus 1. Or put brackets around that so that you can see who you're matching with and what you're going to try to basically, or what you're going to basically factorize. Okay, the bottom will leave exactly the way it is. Okay, now let's factorize. Take out a common factor. Now when we take out a common factor of x to the power of n, that will leave us with x to the power of 2 minus 1. So we take out a common factor of x to the power of n, it will leave us with x squared minus 1. So far so good. Matches with the bottom. Same story over here. Take out a common factor of x to the power of negative 1, x to the power of n minus 1, I mean. And to get back to x to the power of n plus 2, you'll have to multiply that by x squared minus 1. Alright, so now we have that common factor. The next step is to take it out. So that's x squared minus 1. So now let's take out that common factor here. X squared minus 1. Take out the common factor x squared minus 1, and that would leave us with x to the power of n plus x to the power of n minus 1. And at the bottom we have x squared minus 1, and the x squared minus 1 cancels with this x squared minus 1, and that leaves us with simply x to the power of n plus x to the power of n minus 1, which is the correct answer. Next question. 2.1.3 goes simplify without the use of a calculator, and you've got the square root of this times the square root of that. Now if you notice this, it's almost like a difference of 2 squared. It's the same thing. We have a plus here and a minus there, so that makes it a difference of 2 squared. So what we do is we have everything under the same square root, so that will be the square root of everything will be under the same square root, and then we bring this together. Okay, that's what the effect of multiplying a square root by another square root gives you. So that multiply by the other one, so that will be a minus square root of 2a minus 1. All right, now this is a difference of 2 squares. So what we do now, that gives us the square root of, all right, the difference of 2 squares will be the first term squared minus the second term squared. So that will be a squared minus the square of the second term, square root of 2a minus 1. Okay, let's fix that. We square that. All right, so a squared is just a squared. It's just a squared minus the square root of this. We basically just taken out the square root sign, and that leaves us with a quadratic expression minus 2a plus 1. Please make sure that you treat your integers very, very well. And when we factorize this, it gives us a set of two brackets, a and a, 1 and 1, and they give you -1, which is basically this all squared. So that is equals to the square root of a minus 1 all squared. And the square root of a square is simply that number. So that leaves us with simply a minus 1. And that is your answer. That's how we simplify that. And now for the last question, 2.2. We're given this and we are supposed to determine without the use of a calculator the values of x, y, and z. Alright, so we obviously are going to use the method of rationalizing the denominator, so keep that in mind. We're going to use that. It's going to come in very handy. So this is what we have and we start with. So what we do is we divide throughout by this bracket 1 minus root 2 so that we can have our x, y, and z on one side. And then rationalize the denominator. So we divide both sides. That will leave us with x plus y root z on the left hand side, and on the right hand side it will leave us with -3 plus root 2, -3 plus root 2 over, that is over 1 minus root 2, 1 minus root 2. Now the next step is to rationalize this denominator. So we go x plus y root z equals to, when we rationalize, we multiply the denominator and the numerator by a difference of two squares type of situation. So to match the denominator that we want to rationalize, we must multiply it by a difference of two squares type of factor. This is not changing anything because that over that is simply 1. So basically you're not changing anything because you're multiplying by 1. All you're doing is you're changing how this looks, but you're basically changing nothing. And now we apply the laws of multiplication. So this one at the top will be multiplied by this one, and the one at the bottom will be multiplied by its difference of two squares twin. Right, so we go so that will be 1 minus root 2 multiplied by 1 plus root 2. That's what the denominator is going to be like, and the numerator is simply going to be -3 plus root 2 multiplied by 1 plus root 2. I just wanted to see what we're doing so that you can follow through without any problems. And that is equals to, okay, the numerator, okay, let's start with the denominator. The denominator will be the square of the first term minus the square of the second term. That's what the difference of two squares does. All right, so that will be 1 squared minus -√2 all squared. So that's minus √2 all squared. Does not matter. It's going to give us a plus anyway. So, all right, and at the top, that is -3. We use FOIL here. And then -3√2. And this 2, just √2. And then the last one, 2. √2 times √2, that will be √2 all squared, which we know to be 2. Obviously, I just wanted to follow. All right, so that we will have -3, 1 goat minus 3 goat. So √2 minus 3 √2, that will give us -2 √2, and that will be +2 because it's √2 all squared. +2 all over 1 minus 2. 1 minus 2 equals to negative 1. So that gives us 2 minus 3, that is minus 1. Minus 2 root 2 all over negative 1. Take out a common factor of negative 1. That leaves you with 1 plus 2 root 2 over negative 1. The negative ones cancel out. The negatives cancel out. And that leaves us with 1 plus 2 root 2. And that's your answer. So now we match. So we've got 1 plus 2 root 2. Now let's match. The 1 matches with the x, and the 2 matches with the y, and the 2 under the square root sign matches with the z. So x equals to 1. So therefore x equals to 1. We want to have enough space. Therefore x equals to 1. Y equals to 2. And z equals to 2 is the answer. We've come to the end of this video. Thank you so much for watching. I'll see you in the last part, which is video 4.